Hello guys, welcome to my channel. My name is Vrinder and today we are here to start our new chapter. Okay, so previously I have completed vectors, and those who have not watched vectors, please go through my previous videos. Okay, so today we are going to start mechanics part. Okay, so in mechanics what we are going to study, that I will tell you today, and why it is important for us. And those guys who are preparing for IIT, JEE and NEET, you guys will know that this is the most important part in your examination. Okay, so the topic which we are going to start today is mechanics. Okay, now in mechanics what do we talk about? Okay, in if you see this word mechanics, so everyone thinks that here we have to talk about those things which are related with the machines. Okay, now the whatever things are happening, the phenomena are happening, maybe can be related with the bodies. They can be rotating, they can be in motion. Okay, any kind of a motion. So if you see the motion can be in a straight line, motion can be like this curved motion, it can be a rotatory motion, circulatory motion, any type of a motion. Okay, so whenever one or two bodies are connected or another forces are acting on a bodies, a particular motion gets generated depending upon the different sets of conditions. Okay, so when this motion is getting generated, that all those things, so whenever we are going to talk about motion and everything, we are going to study under mechanics. Okay, now if you see, so you guys might have heard about pendulum in class 9th and 10th, like this motion, pendulum moves like this. Okay, so that also comes under mechanics part. Okay, so in mechanics what we have done, we have divided mechanics into two parts. Okay, first one is kinematics and another one is dynamics. Okay, in kinematics we only talk about the effect. So you guys already know till now that in order to produce a motion we need to have a force acting on that. Okay, and whenever a force acts on a body, a motion will be produced. Okay, it depends whether a motion is produced or not, but let's say a motion is getting produced because of a applied force. Okay, now in kinematics we are not going to talk about the forces. Okay, we are only going to talk about effects, means a body is moving, we will only see that it is moving. Okay, and at what speed it is moving, or it is decelerating, or whatever it is doing, but we are not going to talk about the forces responsible for creating the motion or stopping the motion. Okay, but in dynamics part we have to study both. We will talk about your forces responsible for the motion. Okay, so we are having mechanics and it has been divided into two parts: kinematics and dynamic part. In kinematics we only talk about the effects. By effects I think it is clear to everyone now. Suppose a box is present like this on a surface. Now I am applying a force from this direction. When I am applying a force, this, if my force is greater than this, the force applied by the box, then this box will start moving in the further in this direction, because the direction of the force is in this direction. Okay, so it will move in this. So in kinematics part we will only see that, let's say here x is equal to 0 and here x is equal to 10, means that after some time it has come here. So we are going to study only this portion from x0 to x10, that how much speed it has taken. Okay, so how much speed it has attained, why it stopped, that we won't study here. Okay, so we are going to only talk about the effects of the forces in the kinematic parts. But when we talk about your dynamic part, here we consider everything. Here we will study about we are going to study about your forces and their effects. Okay, so here we will be studying about forces and their effects. Okay, now in kinematics, cause is a noun, we only talk about the effect. Okay, now if those guys who are preparing for IIT JEE and NEET, this thing is very important for them. Okay, if you see every year NEET, JEE and JEE or NEET examination, on an average, if we say that 11th portion is 50%. Okay, the questions from 11th is coming 50%, but sometimes like in 2018 and 2016, 11th percent questions from 11th class was up to 60% questions were. Now on an average, let's take it's only 50%. Okay, now if 50% is coming from the 11 and the maximum questions which come from 11 are from mechanics parts. Okay, so it makes it very important, and the topics which are present in this one are very easy. Okay, so let's discuss about the topics which we are going to study in mechanics first, then we will start. So in mechanics, we will first chapter we have to discuss about is that your kinematic part. Okay, so I think now it is clear to everyone that in kinematics we will be talking about the motions. Okay, now after studying motion, we will move towards the dynamic parts. So means we will be going towards Newton laws of motion. Okay, in short we write it like NLM. Okay, so after kinematics we will be talking about Newton's laws of motion, then after it we will be talking about friction, then circulatory motion, friction, circular motion, then after this we will be talking about work, power, energy. Okay, and in short we write it as WPE. Then we will be talking about center of mass and your rotational motion. So these are the 7 chapters which we have to cover in mechanics. Center of mass, so in short we will be writing as COM, and then rotational motion. Okay, so these are the 7 chapters which we have to study in class 11th. Okay, and these are very important because maximum questions are going to come from this portion. Okay, 50% on an average, I am saying that 50% questions in JEE and NEET are from class 11th, and from that 50% the maximum questions are from these 7 chapters. There are other chapters also. Physics is not limited to these 7 chapters. There are other chapters also, we have to study them, but we have to focus on them because if we are done with these one, it can help us to better our rank in the examination. Okay, now if you see these things, we are having kinematics, we are having Newton's law of motion, we are having friction, we are having circulatory motion, circular motion, work, power, energy, COM, rotation, and can you guys see that all these chapters are related with the class 9th? This is the reason you guys, some guys might find it difficult, all connected with class 9th. Okay, so some students find it difficult because all these are connected with the class 9th. Okay, because you guys have forgotten class 9th now. Okay, so you have to remember everything again. Okay, so those who remember class 9th, they are good to go, but you guys do not worry, we will be covering everything in depth here. Now before this, in kinematics parts, we can say the units and dimension and your vectors are also part of it, but I have already covered unit and dimension and vectors. Okay, why I have covered them? Because if you take whole syllabus of physics, okay, unit and not physics, chemistry also, yeah. So in that, though both the subjects, we are having application of unit and dimensions in whole of the syllabus. Okay, now here comes, all these chapters are going to have applications of your vectors. Okay, so vectors is a very important. Vectors is not going to leave you guys. Okay, so you need to study vectors first, then comes to the mechanics part, and those who know vectors, they can start with me. Okay, so next, so let's start with the kinematics parts first, then we will move towards Newton's law of motion, friction, circular motion, WPE, COM, and rotational motion. So shall we start? Yes, we should. So in kinematics part, so there are certain definitions which you guys should be aware of. So let's start with them first. So we are starting with the kinematic part. Okay, in kinematic parts, the first thing which you guys should be knowing is motion. Okay, so we will talk about motion. Okay, so why I am going to talk about motion, because there are some students who do not understand its meaning clearly. Okay, so when I ask about motion, some students say that whenever an object is in motion, or not motion, whenever an object is moving, we say that it is in motion. Okay, so this is not a complete definition. Okay, so in order to define a motion, a body is said to be in motion when it is changing its position with respect to time. Let's say at time t1, I am standing at this corner. Now I have started moving and I am running at a very fast speed. So I have reached this location. Okay, so let's say at time t2, I have changed my position, because at time t1 I was standing at that corner. Now at time t2 I am standing at this corner, so my position has changed with respect to the time. Then only I will say that I have done a motion. Okay, so in order to define a motion, what do we have to say? That a body is said to be in motion if it changes its position, its position with respect to time. Okay, so if a object or a particle is changing its position with respect to a time, we say that it is in motion. Now here, this is not an easy concept to understand. You have to understand it in depth. Okay, so first let's talk about motion. When we can create a motion. Okay, so this thing you do not have to study in kinematics part, this is in dynamics part, but let me give you an overview here, that why we are studying it. Okay, let's say we are having an object placed like this. Okay, so here its weight, it is acting downward, so this force is keeping it here. There are other forces also, frictional forces also, then you guys can say air resistance also. Let's ignore all those things. Now I am applying force from this side. Okay, I am applying force from this side. Okay, so there are three possible scenarios, that my force is going to be less than weight, it is going to be equal than weight, it is going to be greater than weight. Okay, so in this case, when this force is less than its weight, I must not be able to move this block. Okay, so in order to move this block, I need to have force which is more than the weight. Okay, so we need a force which is more than the weight. Okay, so which in these two scenarios, motion is not produced. Okay, and only in this case a motion is produced. Motion is produced. And if you see, this is my unbalanced force. Here we are having unbalanced force. Here also we are having unbalanced force. In this scenario, we are having balanced force. So we can say the motion gets produced only during unbalanced forces. Okay. So these things we will be talking about in details when we will be talking about your dynamic portion. I'm just giving you a heads up here. Okay. So here motion we have studied, that I have tried to explain it with a very simple definition, that when it is changing its position with respect to the time, we will say that the object is in motion. Okay. Now here I have used a particular word position. That is why I have written it in capitals, that how do we define position. Okay. Let's say I am standing here. Now you guys want to define my position. How you guys will define my position? Okay. So one of you might say that I am standing in middle of the whiteboard. Okay. So there is a not there. I don't think there is another way of defining my position here. Okay. So you will say that sir is standing at the center of the whiteboard. So what did you do? You took whiteboard as a reference. Okay. So you took a whiteboard as the reference point. So with respect to the whiteboard, you measured my position. Okay. So this thing you need to understand, what is position. So position is always measured with respect to a reference point, and position tells you the location. Okay. In short, some can say that it tells us the location, and here we always try to define position with respect to, I am going to write in short, with respect to a reference point. So usually when we are solving questions and everything, we try to take that reference point as origin. So I am going to write it in brackets. So we usually take it at origin. Let's say we are having a particle present at this point, and I want to define its position. So what we will do, we will take an xy plane here, x, y, and this is origin. Okay. And what we will do, we will try to measure its coordinates here, x1, y1. Okay. So this is going to be its position. Okay. So we are trying to define the position of the particle A with respect to the x and y coordinates here. Now in vectors, we have studied this line here from the origin represent its position vector. Okay. So how do we define position vector? Let's say this is x, let's say this is y. Okay. So position vector, how do we define position vector? This thing we have studied earlier also. Position vector, which is r is given by x, and this x is in the direction of x coordinate, and for x coordinate we use I cap. So xi plus yj cap. So this is how we define position vector. So I'm just making you guys remember what we have studied in your vectors, because vectors is going to have a massive application in your kinematics, not kinematics, whole of the mechanics. Okay. Now here I have defined position with respect to the origin, but it is not always going to be the case, because if you talk about JEE advanced and everything, then they are not going to make it easy for you guys. They are going to make it difficult for you guys. Because why? Because this is easy. In NEET you guys can expect questions with respect to the origin, but JEE advanced, it is not going to be easy. So they are going to give you particles. We have to, so let's say we are having a particle like this with respect to this position, we have to measure its position. Okay. So this is going to be the position here. So these things how we can solve, we will do when we will be solving some questions. Okay. Now here, so we are done with motion. So in motion we have studied that we need to know about the position, with position, and how do we define position, that also we have discussed. So in order to define a body is in motion, we need to know whether it is moving with respect to time, or we can say with respect to a reference point. Because I am standing here, let's say I'm standing still, my position is not changing here. if you see that I am still at the center of the whiteboard. So you guys might say that I am at rest. I am not moving because my position has not changed. Let's say at time t1 I am here, at time t2 also I am here, time t3 also I am here. So my position is not changing, but I am also at motion. Okay, if you see, you know that earth is moving. Okay, earth is moving, so all of the particles which are present on earth, they are also moving, but all those are moving with respect to the sun or other planets. Okay, so I am in motion with respect to the sun because my position is changing, but I am present here in front of you at a single location. So you guys will say that I am at rest. So a body can be at rest as well as a motion at a same time. Okay, so at a same time I can be at rest, but I can also be in motion. Why? Because it is all because of the reference point. Okay, so we have to choose and see the reference point very carefully, that if we want to see a body, is it rest or in motion. Okay, so I hope this is clear to everyone. So next, let me give you a scenario, then on the basis of that scenario we will study new definitions. So let's say, so few days ago, I went on a road trip. I started from Delhi, okay, and I reached via Manali, LA, Ladakh to Jammu. Okay, so when I was at Jammu, I saw the route from the Google Map. So Google Map showed me two different ways. Let's say this is Jammu, and here we have to come to Delhi. Okay, so when I navigated from Jammu, it showed me three different ways. So one path was like this to reach my location, one path was like this, and one was like this. Okay, so let's say here the distance is x1, here x2 and x3. Okay, now Google automatically selected x2 path for me because it wanted me to save time, and I also want to save time, and I also want to travel less distance. I do not want to cover, so let's say this is 100 kilometers, this is 150, this is 300 kilometers. So if I have to reach from here to here, why would I travel this 300 kilometers unless until I have to cover some destinations here. Okay, so Google selected this one for me automatically. Okay, now here these paths were shown when I selected there that I am going to travel by car or bike. Okay, now there is another possibility here. When I selected that, if you see maps these days, they show air route also. Okay, so in case of air route, means that by flight it shows direct path. Okay, so let's say this is x4. Okay, now in this diagram you guys can clearly see that x4 is smaller, this is smaller than, so largest one is x3, then x2, x1, x3. So if you guys can see, this is the path relationship between them. Okay, so the first term which we will be defining is your distance. So what is distance? If I traveled from this point to this point and I took this path, so distance traveled is going to be x1. Okay, so how do we define distance? Distance traveled is defined as the actual length of the path traveled, actual length of path traveled by a particle, or you guys can say an object. Okay, now let's say I have traveled from this one. Okay, so let's say this is 100 kilometers, this is 1, this is 200, this is 150, this is 300 kilometers. Okay, all of these are in kilometers. Okay, now if I have taken x1 path, okay, so I would have traveled 200 kilometer. Okay, if I have taken x3 path, I would have traveled 300 kilometer to reach my destination, and if I have taken x2 path, I would have traveled 150 kilometers to reach my destination. And if I have taken x4, and x4 is by air method, okay, so in order to travel by road, I should take x2, okay, to reach destination. So all these are distances traveled, because if I am traveling from any of these paths, this is the actual length I am going to travel. Okay, so I can reach this destination from any four ways, but the distance traveled is going to be different. Are you guys getting my point here? Okay, so here the actual length of the path traveled by particle gives you the distance traveled. So in exam, in question, sometimes it says distance between two particles, sometimes it says distance traveled. So do not get confused with the terminologies. Just whenever you see a distance, see what path he has taken and for how long he has traveled. So here I'm not going to talk about speed and distance, time. Okay, so those things I will introduce later on. Just understand the concept here, that here if I have to go from this position to this position, okay, I have to travel distance. Okay, so I can take any direction. Can I, is there a particular direction in which I go? I can go in this direction also, I can go in this direction also, I can go in this direction. So from here, can we conclude that distance is independent of the direction? Okay, so though we need to travel to reach my destination here, but I can travel in any direction. I can take this path also to reach my destination. Though my initial and final stages are fixed, but I can travel in any direction to reach my destination. Maybe I will reach there after 50 years. Okay, so that is not the point here. So from here, can we say that it do not need direction? It only has magnitude. Like here it is having 300 kilometers, here we are having 150 kilometers, here we are having 100 kilometers, here we are having 200 kilometers. So those quantities which have only magnitude, we call them as scalar quantities. So distance is a scalar quantity. Now another thing which you guys should know, that if I'm traveling from Jammu to Delhi, I have to cover some distance. Okay, it is not like that if I am traveling zero distance I can reach Delhi. Okay, so there is a minimum path. Minimum path is 100 kilometer, which is by air. Okay, 100 kilometers, so at least I have to travel 100 kilometers. So its value, when we talk about magnitude can be your positive, it can be your negative, it can be zero. Okay, so there are three possibilities in magnitude. Okay, but can magnitude be negative? No. Okay, so you will find that there are some scalar quantities which have negative values, but there are other processes involved in those scenarios. Okay, so magnitude here our is going to be positive or zero. But in order to, if I am changing my position from location 1 to location 2, I am covering some distance. So distance is always going to be positive. So it is always positive. Now what is SI unit of distance? It is SI unit meters. So SI unit of distance is meter. Okay, so I hope it is clear to you guys. Now let's say here this is my aerial path. Okay, this is my aerial path. Aerial path between the initial point and the final point. Okay, so usually whenever your flights flew, they take this path. Okay, so this is taken by this one. Now aerial path, if you see, this is the shortest distance between them. So aerial path is the shortest path. Okay, so shortest path is known as displacement. Shortest path is known as displacement. So next we are going to talk about displacement. So I'm going to rub this portion. I'm going to keep this diagram here because I'm going to use this one. So I am starting displacement. So how do we define displacement? It is the shortest path between initial and final point. Okay. So here initial point was Jammu and final point was Delhi, and the shortest path here is 100 kilometers. So this is my displacement here. Okay. So the shortest position between the initial and the final position, shortest path between the initial and the final position is termed as displacement. Okay. Now here if you guys see, there are two scenarios possible. So all of earlier I have told you that all of these are distances traveled. Now from here you guys can see, say that distance is greater than displacement. Now some of you might say that if I am taking this path by road, then I can reach this destination. So we can have a possibility when distance is greater than displacement, is sorry equal to displacement. So distance can be equal to displacement, but it can never be less than displacement. So can you guys see? Displacement is already the shortest path. Okay. Displacement is already the shortest path between initial and final position. Then how come distance can be less than that? Okay. So this is the reason why distance can never be less than displacement. So distance can never be less than displacement. Now if I combine these things in some books, you guys might see that it is written as the distance is greater than or equal to displacement. So this means the same thing in combining both things. When I'm combining both of these, the distance is always going to be greater than or equal to displacement. In some cases it is going to be equal to displacement, and in some cases it is going to be greater than the displacement. Now another thing which you guys must understand here, that if I want to find the displacement, okay, if I want to find the displacement, then I have to travel at this path only. I cannot take any other path. Okay, so this path is fixed. So here I have to travel in this direction only. If I am traveling in this direction only, then only I am going to reach my destination. Okay, and it will give us displacement. So it is dependent upon the direction. Can we say that or not? So it is dependent upon the direction. So from here we can say that displacement is a vector quantity. Now, okay, I hope it is clear to you guys that it is a vector quantity. Now I am saying I have defined this thing as it is the shortest path between initial and final point. Okay, it is the shortest path between the initial and the final point. So other things are same. It is vector quantity, SI unit stays the same, it is meter only. So another thing, it can be positive, it can be zero, or it can be negative also. So that thing I will explain. So first, let's talk about your displacement vector. We have studied that in vectors. I hope you guys remember that now. So we are going to talk about displacement vector first. Then I will show you that how I can say that it can be positive, it can be negative, or it can be zero. So here we are going to talk about, let's say we are having a particle present here at position A, and we are having a origin like this, and we are having another particle present at point B. Okay, now this is its position vector r1, and its position vector is r2. Okay, and it is having coordinates x1 y1, and this one is having coordinates x2 y2. Okay, so let's say the particle has moved from A to B. Okay, so how do we define A to B? It has come like this. So this is written as del R. This is your displacement vector. Okay, so this we have already studied in detail in vectors. So this is your displacement vector. Okay, now displacement is a vector. This, guys, you guys know. Now it can be positive, it can be negative, or it can be zero. Okay, so here del R is representing your displacement vector. Now how do we define del R? If you guys do not remember, see my previous videos. R2 minus R1. Now, how do we define R2's value? R2 is, let's say this is X2 and this is Y2. So, R2 is X2 I cap plus Y2 J cap minus R1. Similarly, R1 will be X1I plus Y1J, X1 I cap plus Y1 J cap. So when I will open this bracket, it will become X2 I cap plus Y2 J cap minus X1 I cap minus Y1 J cap. Let's bring X components together. So it is going to be X2 minus X1 I cap. Similarly, we will be having Y2 minus Y1 J cap plus. Okay, so this is my displacement vector. So I hope you guys remember this one. So how do we calculate its magnitude? Calculating magnitude is simple. I'm just revising it for you guys. X2 minus X1 whole square plus Y2 minus Y1 whole square. Why I'm not taking this portion? Because here both of them are perpendicular to each other, so it will become 0. And how this is my magnitude, this is my vector. And if I want to talk about its direction, direction is given by unit vector. So that is written as like this, cap. Okay, so that is equal to vector divided by magnitude. So this much revision is enough for you guys, I think, of vectors. Okay, so if I put these, divide this value, this value by this value, I will be getting unit vector, which gives us the direction of the displacement vector. Now let's go and try to find how it can be negative, positive and zero. I hope this have jogged your memory up. So let's start. I will explain that how I am saying that it can be negative, it can be positive, or it can be zero. Suppose we are having a body placed at point A and it has to cover a distance and reach here. Now let's say this is the x distance it is going to travel. Now if I say that a body is traveling from A to B, okay, if a body is traveling from A to B, let's say what is the distance traveled. Now all of you will say that distance traveled is x. Now if I ask you what is the displacement traveled, you will also say that it's x because I have drawn it as a shortest path between A and B. Okay, so this thing is clear to everyone. Okay, now if I say that it is coming from B to A, okay, now I am saying that it is coming from B to A. Now my initial point is B, final point is A. Okay, now here you guys will also say that distance traveled is x, but what about distance, displacement? Okay, now what about displacement? Now displacement has a direction. Previously, when it was traveling from A to B, I took it in positive x direction. Now it is moving in the negative x direction. So can I keep it positive? I cannot keep it positive. I have to keep it negative because it is in the opposite direction. Okay, so the displacement here is going to be minus x. So in this direction it is x, in this direction it is minus x. Okay, now if you see the whole scenario, the body started moving from A to B, B to A. So from A to A. Okay, so here initial point is A and final destination is also A. Okay, now it traveled, distance traveled. Distance is the actual path traveled by an object. So it started moving from A to B. It traveled x kilometers. Then all again it traveled from B to A. It again traveled x kilometer. Okay, so suppose you are going to movie. Okay, you are going for movie and you saw in your odometer, आपकी car है ना, you guys have a car in your house or a bike in your house, you have an odometer, so it shows a distance. Okay, there is a distance, odometer measures distance. Okay, so you have seen the reading. So let's say you have seen the reading here is 410. Okay, now at it, and here you are having a movie hall. Okay, so you went here and you saw here your reading is 450. Okay, so how much distance you have traveled? You concluded that I have traveled 40 kilometers to reach the movie hall. Now after movie you started your car again and you started from here and you reached here, and here your odometer reading was 90. 490, because the same distance you have traveled in this direction, the same distance you are going to travel backward also. So when you saw that initially my odometer reading was at 410, now my odometer reading is at 490. So what is the distance traveled? 80 kilometers. So you have traveled 80 kilometers, 40 kilometers in that direction and 40 kilometers in that direction. So distance traveled is 80 kilometers. So similarly in this example we are having x, so x is going in this direction and x is going in this direction. So x plus x will be 2x. So what is the distance traveled? X kilometer, 2x. Now when we talk about displacement, we have to think about the initial and the final position. So initially I was at A, okay, and finally I am again at A. So you guys will directly say that it is 0, okay, because my position has not changed, okay, with respect to the time, but I have traveled the distance. Okay, so that comes under distance. But how does that come? That comes here, that in this direction I traveled x kilometers, but when I am moving from that particular movie hall to my home, I again traveled x distance but in the opposite direction. So when I add this up, x plus minus x, it becomes 0. This is the reason why we say that the displacement can be 0 and it can be negative, it can be positive. I hope it is clear to everyone. Okay, so now let's do a question, not a question, let's revise all these things, that distance and displacement, whether you guys have gotten the point or not. Let's say we are having an initial point A here and we are having another point B here, okay, and this distance, so it is moving in a circular motion. We can say it is a circular motion. The radius is r. Okay, now it is A to B. Let's mark it, okay, different names. Let's see, this is D. Now I want to find my distance as well as displacement. Okay, when I traveled from A to B and A to C and C to B and A to D, I want to find what distance I have traveled and what displacement I have covered when I have traveled from these locations. So let's see, when I am traveling from A to B, now A to B, the path taken, let's say it is like in this direction, it is moving clockwise. Okay, so distance traveled will be this path, it has taken like this. So this length of this path is given by the circumference of a circle, and circumference of a circle is given by 2 pi into radius. Radius area I have given r, so it will be 2 pi r. Okay, but here it has not traveled the whole circle, it has traveled half the distance. So here the distance is going to be pi r. What about displacement? Displacement is the shortest part between the initial and the final position. A to B, if this is r, this is also going to be r, so diameter is twice of r. Now let's come to A to C. Okay, now A to C. Okay, so here the distance traveled is going to be, it is 1/4 now, it is 1/4. If this is pi r, this distance is half of that, so this is going to be pi r by 2. But let's come to the displacement part. Displacement is going to be like this. This is my displacement. If I connect, this is also r, this is also r, and this is making it a right angle triangle, and this is going to be root 2r. This is going to be root 2r. Okay, now you guys can solve the r square plus r square is equal to hypotenuse square by using Pythagoras theorem. So my displacement here is root 2r. Similarly, when it is moving from C to B, same scenario, it is going to be pi r by 2 root 2r. Now C to B, A to D. Now we have to see A to D. If this is pi r and this is pi r by 2, it is going to become 3 by 2 pi r, sorry, 3 by 2 pi r. Okay, and what about displacement? Displacement is going to be same. So similarly, what you guys can do, you guys can construct more examples and try to solve some questions. Then only your concepts are going to be clear, and this portion is very, very, very important. Okay, so do not skip this portion, kinematics part. Invest your time in kinematics because it is going to improve your rank. Okay, so I hope you guys have enjoyed my lecture, and those who have enjoyed my lecture, please do like and subscribe my channel. Thank you guys, and we will meet tomorrow, and tomorrow I will start from here and I will teach some new topics. Okay, thank you guys.